Hello students, let's welcome to our YouTube channel Physics for UG. So in this video we shall discuss about Fresnel's half period zones. So what are basically Fresnel half period zones? So basically in diffraction part there are two types of diffraction. One is Fresnel, another is Fraunhofer diffraction. So in the Fresnel diffraction part we shall discuss first part is Fresnel half period zones. So whenever light waves traveling in space, they set the hypothetical ether particles in vibration. That means the particles in the vacuum or the particles in space, and these are ether particles, and ether particles are not actually they are present. That's why they are known as hypothetical particles, and the particles are vibrating due to the light waves. Okay, the continuous locus of the ether particles in the same phase of vibration is called wavefront. This is the actual definition of wavefront. What is wavefront? So wavefront is basically the continuous locus of the ether particles in the same phase of vibration. That means in a wavefront, the particles are always in the same phase and they are vibrating in the same phase. That is the wavefront. And by using this wavefront, there is a principle known as Huygens principle. So according to Huygens principle, each point on wavefront sends out secondary wavelets. Okay, then Fresnel assumed that these wavelets interfere and produce resultant intensity of light at any point. So what are secondary wavelets? What are primary wavefronts? So these are already discussed in Huygens principle. This is the brief idea about Huygens principle. Okay, next is, in order to calculate the resultant intensity at a point due to wavefront, Fresnel divided the wavefront into a number of zones called Fresnel half period zones. So what are half period zones? So first of all, let's look at to calculate the resultant intensity at a point due to a wavefront. So there is a wavefront and you need to calculate the intensity due to that wavefront. So Fresnel did what? So Fresnel divided the total wavefront into a number of zones. So basically the wavefront is divided into a number of zones, and each zone and this type of zones are known as Fresnel half period zones. So from the diagram, let's discuss what are Fresnel half period zones. Okay, so how they can be constructed. First of all, look at this figure. These are basically the half period zones, Fresnel half period zones. So how they are constructed? So there is a plane A, B, C, D, and this is the point P. Okay, now we draw normals from this point P towards the plane, and we draw small circles. This is the first circle, this is second circle, third circle, fourth circle. So such type of circles are there. So what is the distance from this point P towards the circle? The first one is P plus lambda by 2, second one P plus 2 lambda by 2. This is the second one, this is the first one, and this is the third one. The third length of third one P plus 3 lambda by 2. Then and the last one P plus n lambda by 2. And these are the different lengths of the normals which are drawn towards the plane ABCD. Okay, let's look at the construction, how they are constructed. Let ABCD be a plane wavefront of light of wavelength lambda. So basically ABCD in the figure is a plane wavefront, and P be an external point where effect to be observed, and all the effect of intensity we have to observe at the point P. Now let's draw perpendicular PO to the wavefront PO. The length is P, the first line, the straight line. So in the figure, this is the plane, and from this is the center, and from the center this is the P point, and we draw from P towards the normal, that length is PO, that is P, and draw a series of spheres with P as center and radii P plus lambda by 2, P plus 2 lambda by 2, P plus 3 lambda by 2. What we did here, we draw a series of spheres with P as center, this P as the center, and we draw different spheres of radii p plus lambda by 2 as shown in the figure, p plus 2 lambda by 2, p plus 3 lambda by 2, p plus 4 lambda by 2, and then p plus 5 lambda by 2, and so on. And the last one will be p plus n lambda by 2, p plus n lambda by 2. Okay, listen carefully. The area of the first, which is the innermost circle, is called the first half period zone. So the initially the first one is the first half period zone. The area between the first and second circle is called second half period zone. So the area between second and third is called third half period zone, and the area between n minus 1th and nth is called the nth half period zone. So you can easily understand from the figure. Now look at the figure. So from this part, this is the diagram. So the length is p. So the first length, so from O to P, the first length is p, and the next one is p plus lambda by 2, and next is p plus 2 lambda by 2, and the area inside the first region is the first half period zone. So this region is the second half period zone, this one is the second half period zone, and this one is the third half period zone, this is the fourth half period zone, and this is the fifth, and so on. So we have to calculate, we have to study different intensity parameters and amplitudes due to the half period zones. Let's discuss one by one. Okay, so what is the area of a zone? What is the area of nth zone? Okay, so from this figure, look at here, this point is, the center point is O, and the last one point is Mn, and this is Mn minus 1. So this figure, this region is the nth zone, because this is in between the n minus 1 and n. So this is the nth zone. We now calculate the area of this nth zone. So what will be the area? So this is actually circular shape. So the area, the circle area formula is pi r square. So from this figure, if we suppose take this is one circle and this is another circle. Okay, if this area is, this radius is r1 and this radius is, and bigger one radius is r2. So what will the area in between these two? That is pi r2 square minus pi r1 square. So pi r2 square is the bigger area of the circle, bigger circle area, and pi r1 square is the smaller circle area. So we subtract from the bigger to the smaller, then we get the area in between the two circles. So similarly, what will be the area in between the two circles? That is pi OMN. OMN is the, this one is the OMN minus OM minus 1. OMN is the radius of the nth circle, and OM minus 1 is the radius of the n minus 1 circle. Now look at here, what is area of a zone? The area of nth zone is pi OMN square. Okay, look at this figure, this one, pi OMN square minus pi OMN minus 1 square. So pi OMN square equal to PMN square minus PO square. Look at the figure, OMN square equal to PMN square. So from this part, so from this circle, this is, and this one is a right angle triangle. So this part is H, this part is, and base, this part is P. So from the Pythagoras theorem, P square is equal to H square minus B square. So using this formula, we can find from this figure, that is OMN square equal to PMN square minus PO square. Similarly, from these two parts, pi is taken common, and minus PMN minus 1 square minus PO square. So what is PMN square? That is P plus n lambda by 2 square minus what is PO? PO is the first line, that is P square. Okay, minus what is PM minus 1 square? P plus n minus 1 lambda by 2 whole square minus P square. So what will be the value? by using the method that is p plus n lambda by 2 whole square. That means p n lambda n square lambda square by 4. So how you can find? Look at this part will be a plus b whole square. That will be a square plus 2ab 2 into p into n lambda by 2 plus b square, that is n lambda by 2 whole square minus p square. So next part is bracket part minus, similarly p plus this much square, that is equal to p square plus 2ab 2 into p into n minus 1 lambda by 2 plus n minus 1 raw whole square into lambda square by 4 minus p square. So this part, and this is, and look at, there is a first part p square, and that is 2p n lambda by 2, 2 to cancel out becomes p n lambda, and the third part will be n lambda by 2 whole square, that is n square lambda square by 4, then minus p square, then this is also minus p square plus, so that part will be, if you use the bracket, if you use the bracket, actually this is plus, and last part is minus. So this p square and this p square are cancelled, as well as first p square and first p cancelled. So the remaining part will be pi into p n lambda. This part is p n lambda plus n square lambda square by 4 minus p into this 2 to cancelled minus p into n minus 1 into lambda minus n minus 1 square lambda square by 4. Clear? So from the next, so pi p lambda plus lambda square by 4 n square minus n minus 1 whole square. So you can take common, that is p n lambda, open the bracket, that is p n lambda plus n square lambda square by 4 minus, this is p, this is n, this is lambda, that is p n lambda. Okay, the next part is, this is minus p, this is minus lambda, that will be plus p lambda. This part minus p and a minus 1, this is lambda, the plus p lambda. So the last part will be minus, keep it as usual, n minus 1 square lambda square by 4. So what will be the result? This p n lambda cancel out, so the remaining part is p lambda. Take it initial p lambda, then take lambda square by 4 common. So from the first part it will be n square, from here it will be n square, and the last part will be n minus 1 whole square. Okay, that is p lambda plus lambda square by 4, n square minus n minus 1 whole square. What will be the value? N square minus n minus 1 whole square, which is equal to n square. If we use n minus 1 whole square from the formula a minus b whole square, n square minus n square plus 1 minus 2n, keep it bracket. So n square cancel out, that is plus 1 minus 2n. So if we take minus sign inside this minus into the bracket, that will be 2n minus 1. So use here, that is 2n minus 1. Okay, next, this is approximated to be, this approximation will be pi p lambda plus this much will be pi p lambda, because what is p? Here p is the distance from p to o, and that is very much greater than lambda. So this lambda square can be neglected as compared to p from the first term, because lambda square is very small quantity as compared to p, so we can easily neglect, and so that lambda square term can be ignored as compared to p lambda in the above. That is, the area of each zone, that is pi p lambda, is approximately the same free from the order n of the zone, because I have already told you that this is the first half period zone, this is the second, this is the third, this is the fourth, this is the fifth half period zones. So the area, this is the area. The area of the half period zones is independent of n. There is no n, but that is approximately no n. So order of n, the area is independent of the order of n. So first order the area will be pi p lambda, second order the area will be pi p lambda, third order the area will be pi p lambda. Strictly, but actually remember, but actually the area increases slightly with n, because there is a n quantity, there is actually n present, but that n, due to that n factor, the area increases by a very small amount. So we can take the area are approximately the same, approximately same. Now next part, let's discuss the average distance of nth zone from P. So look at the figure. From the figure, this is the nth zone. Nth zone, what the distance from P? From P, what is the distance of nth zone? Okay, actually the nth zone distance will be the average value P plus n lambda by 2. This is the distance of the nth circle distance. And what is the distance of n minus 1 zone? P plus n minus 1 lambda by 2. This is the distance of the n minus 1th zone. So the distance will be in between them. This is the average. So average, this is the nth circle and this value, and from the first, this is the nth circle and this is the n minus 1 circle. If we take the summation and we average it by dividing 2, then you get the average distance of the nth zone. So that will be P plus n lambda by 2 plus P plus, and this n minus 1 lambda by 2 will be, this part only will be n lambda by 2 minus lambda by 2. Okay, so this is, so what will the part? This is P plus P, that is equal to P. This is n lambda by 2, this is n lambda by 2, that is 2 n lambda by 2. And next part is, this is minus lambda by 2, this is minus lambda by 2. So what are the parts? Divided by 2 is there. Okay, now this is 2p divided by, we can write this part is equal to 2p divided by 2 plus, take lambda by 2 as common from the second, from these two parts take lambda by 2 as common, so that will be 2n minus 1 divided by 2. So the result will be, from 2 to cancel, this part is p, so it is written here p. And next part is 2n minus 1, 2n minus 1 lambda divided by 4 minus lambda divided by 4. So this is the average distance of nth zone from this point. So from this point P, the average distance of the nth zone will be P plus 2n minus 1 lambda by 4. Okay, now let's move to the next part. So next thing is amplitude due to a zone. So what is amplitude? Basically, in a wave, this is the amplitude. This is called the amplitude. Okay, now we have to find what will be the amplitude of light due to that zone. Okay, now remember 2 to 3 points. The amplitude of the disturbance P at P due to zone depends on various properties, various points. So first one is, it is directly proportional to the area of the zone. Directly proportional to the area of the zone. Second, it is inversely proportional to the average distance of the zone, because as the distance increases, the light amplitude will decreases. As the distance increases, so eventually, definitely, the intensity of light and the amplitude of light will decrease. So it is inversely proportional. It is inversely proportional to the average distance of the zone from P. And also in the first point, it is directly proportional to the area, because more is the area of the zone, so more will be the intensity and more is the amplitude of light. and third is the directly proportional to the obliquity factor 1 plus cos theta n, because this quantity, the amplitude, depends upon theta. Look at the figure, this angle is theta, so this angle basically theta, and this the amplitude of this light depends upon the angle theta n. Theta n is the angle between the normal to the zone and the line joining to the zone to P. This is the normal to the zone, this is the zone, and this line is the normal, this line is the normal, and this line is the from the zone to the point P, and this angle is the theta. Okay, so from the first part it is directly proportional, so this above part is the area, this is the exact area. Pi already we have derived just before 2 minutes. Pi p lambda plus lambda square by 4 2n minus 1, this is the first. And second, the inversely proportional to the average distance, so this part inversely proportional. And third one is the obliquity factor, that is 1 plus cos theta n. So solving these two parts, solving, what will get? If you take from the above this lambda and from here 1 lambda, take common, that will be pi lambda, and this lambda is taken out, and here 1 lambda taken out. So remaining part is p plus lambda by 4 2n minus 1, and the above part and the below part are cancelled out. So remaining part is pi lambda into 1 plus cos theta n. So that is pi lambda into 1 plus cos theta n. This is the amplitude. This is the amplitude of the zone due to a zone. Now look at here. As the order n of the zone increases, order n increases because this is the first order, this is second, third, fourth, fifth order. As the number n increases, so theta n also increases, because theta n is the angle made by the normal with the zone. If you take higher zones, if the higher order zones, then the angle will be higher. Okay, because that angle of, suppose let's look at the figure. For the first line, this is the line and this is the angle theta 0 degree. For the second, this will be the line and this is the angle theta. For the third, this is the line, this is the angle, so this is theta. For the fourth, this is the line from the zone to the P, and this line is the angle theta. So angle increases gradually, angle increases, so theta n increases and cos theta n decreases. Why? Because as theta increases, cos value decreases, because cos 0 is equal to 1 and cos 90 is equal to 1. As angle theta increases from 0 to 90, the cos 90 is 0, so value of 1 decreases to 0, so cos theta decreases. As you move from angle 0 to 90, the cos value decreases. Therefore the amplitude of the wave at P due to a zone decreases as the order of the zone increases. Okay, amplitude of the zone of the wave at P due to the zone decreases. As you move from first zone to second zone to third zone to fourth zone, the amplitude of the zone decreases. As you move up to higher orders, as you move from first, second, third, fourth, fifth, sixth up to nth order, so definitely up to the nth order, the amplitude of the wave will be eventually 0, will be tends to 0, because that is decreases very slowly, and it will decreases, and at the last that will be negligibly small. Now let's discuss why these are called half period zones. What is the reason behind half period zones, why they are called half period zones? Okay, now look at the resultant amplitude due to the all zones. The resultant amplitude due to all zones, due to the whole wavefront. What is the resultant amplitude? Let R1, R2, R3, R4, R5 up to Rn be the amplitudes due to the first, second, third, fourth, fifth and nth zone respectively. So remember, R1 is the amplitude of the first zone. This is the first zone. Circle, this is the first zone, and R2 is the amplitude of the second zone, and R3 is the amplitude of the third zone, and Rn is the amplitude of the nth zone. They are in descending order in magnitude. We already discussed in the last page that amplitude of the waves zones decreases as the order increases. So this point magnitude. Further, since the average distance of P from two consecutive zones differ by phase lambda by 2, the from two consecutive zones reach P are in opposite phase. What the meaning of that? This is very important point. Whenever the first line length is P and the second line is P plus lambda by 2, the third line is P plus 2 lambda by 2. So what's the meaning of that? For the first line the length is P, the second the length is P plus lambda by 2. What is the difference? Difference is lambda by 2. So from second to third, what is the difference? That is also lambda by 2. Remember, there is a relationship between phase difference and path difference. When the phase difference is pi, the path difference is lambda by 2. So lambda by 2 path difference means there is a phase difference of pi. So pi means what? Pi means 180 degree. So they are opposite to each other. So when one line is towards right and another is towards left, that is 180 degree, or that is pi. So lambda by 2 phase difference means pi is the lambda by 2 path difference. Lambda by 2 path difference means pi is the phase difference. So the consecutive zones means the zones which are nearby each other are opposite phase because they have a path difference of lambda by 2. Obviously they have a phase difference of pi. Hence, if the amplitude due to the first zone is positive, that due to the second zone is negative. Why? If first is positive, second will be negative, because they have the difference of lambda by 2 by path and pi by phase. So pi means opposite to each other. So if one is positive, other is negative. So the first is positive and second is negative. So similarly the third is positive and the fourth is negative. Hence the resultant amplitude at P due to the entire wavefront for the total wavefront will be, this R is the resultant amplitude, means due to all the wavefronts. So first is R1 positive, R2 negative, R3 positive, R4 negative, R5 positive, R6 negative. So at the last that will be Rn. So it will be positive or negative, depends upon whether if it is odd number, that is positive. If n is odd number, for all odd number that is positive, and for all even number this is negative. So by using -1 to the power n minus 1. Okay, now the successive terms R1, R2, R3 gradually decreases. As you know, the amplitude of the waves or the zones gradually decreases as the order increases. Thus R2 is slightly smaller than R1, but slightly more than R3, because R2 is in between R1 and R3. R1, R2, R3, remember R1, R2, R3 are the amplitudes of the first zone, second zone, third zone respectively. So R1 has little bit more, R2 little bit less, and R3 is very less. So R2 will be in between R3 and R1. That's why you can write R2 equal to R1 plus R3 by 2, because R2 value is more than R3 but less than R1. So R2 is in between R1 and R3. So we can write R2 equal to R1 plus R3 by 2. Similarly, we can write R4 equal to R3 plus R5 by 2. Similarly, R6 equal to R5 plus R7 by 2. So what will be the equation? Now R equal to, we can write this R1, write R1 by 2 plus R1 by 2. Then keep minus R1 as usual, then minus R2 plus R3 by 2. This is plus R3 by 2. We break R3 by 2 parts. then minus R4, keep usual, then R5 by 2, then plus, that will be R5 by 2. In this way we can write. So remember here, look at the figure, R2 equal to R1 plus R3 by 2. So here look at the second bracket, R2 equal to, this R2 equal to R1 by 2 plus R3 by 2. So they are cancelled, so this will be 0. So this part will be 0. Similarly this part will be 0. So ultimately the remaining part will be R1 by 2. It depends upon the last term, and the last term being Rn by 2 or Rn minus 1 by 2 minus Rn, whatever be the last part. We don't need that last part, because whether n is even or odd and Rn is very large, R is very large, as the order of the zone increases, the amplitude decreases. In practice, if n is very large, then Rn minus 1, whether it is even or odd, Rn minus 1 or Rn equal to 0, because n is very large. And as you know, the order, as the order of the half period zone increases, the amplitude decreases, and the last part nearly equal to 0, and we take it 0. So what will the remaining part? So only the part will be R equal to, look at here, R equal to Rn by 2. So finally the result is R equal to Rn by 2. Rn by 2. So what's the meaning of that? This R, remember, this R is the resultant amplitude due to the all zones, due to first, second, third, fourth, fifth up to nth zone. This R is the resultant due to all the zones. And what is R1? R1 is the amplitude of the first zone, only first zone. So the resultant due to all zones is equal to first zone divided by 2. That means half of the, that means half of the first zone. That's why these zones are known as half period zones, because thus the amplitude due to the complete wavefront at a point in front of it is just half that due to the first half period zones. That's why they are named as half period zones. So question will be asked, why the half period zones are called half period zones? So the answer will be, the half period zones are called half period because the resultant amplitude due to all the waves or all the wavefronts, all the zones, is equal to half of the amplitude of the first zone. Okay. Thank you. If you like this video, then subscribe the channel and like the channel and share the video. Thank you.